Have you ever just stared at a picture and thought, there is no way that's not a photo? Well, in the world we're about to jump into, you'd probably be right to be skeptical. Today, we're diving headfirst into AI rendering, where machines aren't just learning to see our world, they're learning to imagine and create it completely from scratch.
I mean, just look at this. The way the light hits the surfaces, the shadows, all those little textures, everything about it just screams real. But it's not a single bit of it. This entire scene was dreamt up, pixel by perfect pixel, by an artificial intelligence. And that is the big question, isn't it? How on earth do you teach a machine to make something so convincing? We're way past just programming in a bunch of fixed rules. This is about teaching it how to learn. Okay, so let's get right into it. AI rendering basically flips the whole traditional process on its head. Instead of a programmer telling it, okay, this is how light works, this is how shadows work, the AI just looks at millions of real photos and figures it out. It learns all those super complex relationships on its own. So before an AI can get creative, it has to do its homework. And job number one is mastering reality. It has to learn how to see and rebuild our world with, perfect accuracy. This is the bedrock for everything else. One of the first huge breakthroughs here is a tech called NeRF, or Neural Radiance Fields. Now, forget everything you know about video games building scenes out of little triangles. NeRF imagines a scene as a kind of smart fog. Seriously. It learns the exact color and density for every single point in 3D space. It's a complete, volumetric picture of the whole scene. So how does it actually see? Well, to figure out the color of just one pixel on your screen, a NeRF shoots a virtual ray out into that smart fog. Along that ray, it stops at hundreds of different points and asks its neural network, hey, what's the color and density right here? Then it takes all those answers and blends them together to create one single, perfectly lit pixel. It's an incredible process, and it's why the lighting and reflections look so unbelievably real. Okay, but now let's talk about the new kid on the block, 3D Gaussian Splatting, or 3DGS. If NeRF is that smart fog, think of 3DGS as a kind of hyper-advanced 3D pointillism. The scene is made up of millions of these soft, colorful, semi-transparent little blobs, they call them Gaussians, that are all layered on top of each other. Now, the crucial difference here, the real game changer, is speed. 3DGS is insanely fast. And the reason why is that it's designed to play nice with the graphics cards we already have in our computers. It basically splats all those colorful blobs onto the screen using the hardware that's already there, which means you get this amazing, high-quality rendering in real time, something NeRF just can't keep up with. So, okay, we've got NeRF for that perfect, jaw-dropping realism, and then we've got 3DGS for that incredible speed. It kind of begs the question, right? Is one just better? Well, you know how it is in tech. The answer is always, it depends on what you're trying to do. And this table really lays it all out. You want the absolute best, most realistic image, and you don't care how long it takes, NeRF is your guy. But if you need that amazing quality at buttery smooth, real-time speeds, you're looking at 3DGS. And then you've got other methods, like SDFs, which are awesome for creating super clean, perfect geometric shapes, but they just don't have that photorealistic pop of the others. Right, so AI can recreate our world. Got it. But what about creating things that have never existed? This is where we leave reality behind and get into pure generation. And trust me, this is where things get truly mind-bending. The magic behind tools like Stable Diffusion and Midjourney, it's a technology called latent diffusion models. The best way to think about it is like a sculptor who starts with a block of marble that's just random noise, pure static. The diffusion model is the artist that slowly, carefully chips away at that noise, bit by bit, until a stunning, coherent image appears, all based on what you typed in the prompt. Now, the secret to how these things are so fast and efficient is that they don't work on the huge, full-size image directly. No way. Instead, they squish it down into a much smaller, compact, latent space. Think of it like a super detailed blueprint instead of the actual building. All that magical denoising happens on this tiny, efficient blueprint. And only at the very end does it get decoded back into the final high-res picture. It's the definition of working smarter, not harder. Before diffusion models took over, the big thing was GANs. And GANs worked kind of like a constant battle between an art forger and an art detective. The forger, the generator, tries to make a convincing fake, and the detective, the discriminator, tries to spot it.
It was really powerful, but also notoriously unstable. Diffusion, on the other hand, with its methodical process of turning chaos into order, it's just way more stable, way more versatile, and gives you a ton more control. But the AI's work isn't over yet. It's not just about creating the image. It also acts like a master artist in post-production, taking a render that's already good and just making it absolutely perfect.
And look, this isn't some pie-in-the-sky theory. This stuff is in the software that pros are using right now. V-Ray uses AI to clean up grainy, noisy images in a snap. Twinmotion uses AI to figure out photorealistic lighting instantly. Even the open-source hero, Blender, uses AI denoisers to give artists amazing previews in real time. AI is already here, and it's making creators faster and better. So, if this is what AI is doing today, where in the world is it all going? Well, buckle up, because the next steps sound like they were pulled straight out of a science fiction novel. All of these incredible techniques need a ton of computing power. To get to the next level, researchers are actually looking at quantum neural networks. By using the just plain weird physics of quantum computing, calculations that take our best GPUs minutes to solve could potentially be done almost instantaneously. We're talking about rendering the most complex scenes imaginable in true real time.
The next big frontier is what you could call a GPT for graphics. Just imagine this. You describe an entire 3D world just using words, like a rainy, serene, cyberpunk alley with glowing neon signs reflecting in the puddles. And the AI just builds it. The whole scene, the geometry, the lighting, everything, just appearing right in front of your eyes.
And how are we going to access these incredible worlds? The answer is something called neural compression. This tech can take a massive photorealistic scene and shrink it down to just a few megabytes. That means you could stream huge interactive 3D environments straight to your phone, your web browser, or your AR glasses with no powerful computer needed.
Which brings us to one final really important question. We started this whole journey with AI learning to copy our world. Then we saw it generate brand new worlds from our words. The future is pointing to an AI that's less of a tool we use and more of a creative partner we work with. So, as these systems get to the point where they can truly understand us and build worlds with us, what does that mean for the future of human imagination itself?